Okay, so today we're doing functions, lesson 3. It's actually called functions, so we're going to use that terminology, that word that we had talked about the other day with 2.5 about functions. So it says for each situation, determine which unknown is the dependent variable and which one is the independent. So dependent and independent. Usually this depends on this. This changes because of that. Usually it's the y and the x. So let's take a look at this first example. It says the equation c equals 0.99n represents the total cost for n music downloads. They're saying the cost depends on the number of downloads. So the equation d equals 4.5h represents the number of miles that miles d that Amber can run in h hours. So what depends on the other? The miles depend on the hours she can run. The equation s equals g plus 3 represents the final score of the game S after g goals. So the score depends on the goals made. And I have this one backwards. I said it right, but I wrote it wrong. The miles depend on the hours ran. Okay, so we're going to talk about independent and dependent variables here. So if you go into the next slide, you're going to see quite a few vocab words highlighted there. So a function is a relation, which is a set of ordered pairs, in which every member of the domain, or input, x, is paired exactly with one member of the range, or y. An example, we just kind of talked about some examples. And then we're going to talk about n is independent and dependent variables. To find the value of a function for a certain number, substitute the variable in for x. So basically what this means is we're going to plug and chug. It's just written differently. It looks like an f parentheses x equals 15 times x. So this is your input, or your x value, and you're going to put this in. We're used to seeing this as a way of saying y equals. But instead of being y, it's going to be, they call it f of x. So this is what we call it. We say f of x. And then we'll put a value in. You'll see here in a second. You can organize the input, rule, and output into a function table. We'll see that on the back. The variable for the domain is called the independent. So domain and independent, or domain and x, go together because it can be any number. The variable for the range is called the dependent, or the y, because it depends on the domain. So let's go practice some in here. So if we see f of -3, if f of x equals 2x plus 1, what they're doing is they're replacing that x. So we would replace it as well. We replace all the x's that we see with the -3. So since -3 is replacing the x, you replace the x in the equation. Plug and chug. So we'll bring our equal signs down. 2 times -3 is -6 plus 1. So we know that f of -3 equals -5, and we have our answer. If we look at the next ones we're trying here, we're going to replace this x, all the x's, with the 2. So we just read it as f of 2 equals 2 minus 4, which is -2. So f of 2 equals -2. This is an ordered pair. The x, we put in x is -2. The y that we got was 2. So this is an ordered pair version of what we have, but we're just worried about this one in the box. So if x is 11, replace the x with 11, we would have f of 11 equals a half times 11 plus 5. Well, half of 11 is 6.5 plus 5, that's 5.5 plus 5. Well, that gives us 10.5. So f of 11 is 10.5. So on a graph, if we had to graph these, we would have the ordered pair 10.5, because that was what was x, and then 11. Wrote that backwards. We plugged in 11 for x and got 10.5. There we go. If we had to graph them. So doing the same thing here. We're going to write f of 4, if we say that correctly, equals 4 minus 6. Well, then f of 4 equals -2. There's our answer. Here's another one. Find f of -2. Let's replace all the x's with -2, but we've got a -2 plus 7. Well, that becomes a positive. So we have f of -2 equals 9. All right. When we're using a what do they call this? An input table, a function table. We're going to choose 4 values. The 4 values that I'd like you to choose are -1, 0, 1, and 2, just so that it's really easy to grade. You could pick anything when you're working on something else, but we're going to work with these because it's easier to grade that way. So we're going to fill in our function table. We picked these values. This is where we show our work. So x becomes -1, so -1 minus 7 is -8, 0 minus 7, 1 minus 7, 2 minus 7. And you can see that it's increasing by 1 every time because here's our slope. Y equals mx minus 7. Remember that domain is x and range is y. It does tell us to state the domain. So the domain, when you get to pick the function table, should usually be -1, 0, 1, and 2, unless it doesn't make sense. Like if we're working with a word problem, choose 0, 1, 2, 3, 4 instead, or 1, 2, 3. And we've practiced domain and range before. So there's our domain and there's our range, a list inside fancy brackets. So we're going to try to do the same thing here. Let's pick -1, 0, 1, and 2. Show our work. So 8 minus -1 is 9. 8 minus 0 is 8. 8 minus 1, 8 minus 2. Again, the slope being -1 over 1. Falls 1, runs 1. So that's why this is falling 1 every time. The domain, -1, 0, 1, 2. Range, 9, 8, 7, 6. X values and Y values. Or in this case, f of x values, because those are the same as your y values. Okay. Here we have to identify some independent and dependent values. So this one says a scrapbooking store is selling rubber stamps for $4.95 each. The total sales, f of n, is a function of the number of rubber stamps sold. Identify the independent and dependent. So independent. I like to identify the dependent, really, like what depends on the other one. The what are we talking about? The number, okay, we're talking about cost. So we're talking about the total sales or cost, that depends on the stamps sold. So the cost depends on the stamps sold. What values of the domain and range make sense? Well, so for the domain, the cost, what are they cost? They cost $4.95. Well, can I have $5? No. Can I have $6? No. Everything needs to be in multiples of $4.95. What values of the range make sense? Well, could I have negative stamps? No. Can I have 0 stamps? Sure. So 0, 1, 2, all those make sense, all the way up into positive infinity, but making sure they are whole numbers. Write a function to represent the total sales, then determine the total sales for 5 stamps. So if we were trying to figure out what's the equation for this, we'd probably do y equals 495x, but because we're working with funny function things like this, instead of writing y, we'll write it like this, which they gave us. We'll put in our slope, and we'll put in our x, which happens to be the n. And then it says, then determine the total sales for 5 stamps. So f of 5 stamps equals 495 times 5, which is $5 times 5 is $25, but minus 25 cents, so $24.75. There we go. Let's try another one. A hot air balloon can hold a lot of cubic feet of air. It's being inflated at a rate of 6,000 cubic feet per minute. So here's our slope, here's our m. The total cubic feet of air, A of t, instead of y, is a function of the time of t. Identify the independent and dependent. Well, what depends on the other one? The total cubic feet depends on the time that it gets inflated. So the cubic feet depends on the time that you have inflating it. What values of the domain and range make sense? Well, we talk about domain being our x values or our independent, and our y being our dependent. The domain is our time. We're talking about minutes here, so we need to have whole minutes, or we could talk about 0 minutes, 1, 2, 3. They're not doing half minutes. If they were, they tell us. And the range has to be in multiples of the slope, which happens to be 6,000. Write a function that represents the total amount of air, then determine the amount in 6 minutes. So they ask us to use a of t instead of y equals 6,000 times the time. And then in 6 minutes, plug in 6. 6 times 6 is 36. And then add our 3 zeros. And that would be cubic feet of air. Or we can write feet cubed. Have a great day.